Okay, so good morning. Welcome to this MOOC course on Introduction to Research. So my name is Balaji. I am a professor in the Department of Mechanical Engineering. I specialize in optimization and heat transfer and numerical weather prediction. So these 2 hours we will talk about creativity in research. Creativity is often misunderstood or not understood properly, particularly in engineering. Generally people have a feeling that creativity is very less. So the moment you talk about creativity, you talk about arts, you talk about movies, you talk about right, music and so on. But actually there is a lot of creativity in engineering also, and in research we will have to see how we can use these principles of creativity which have been developed over the past few centuries, so that we can make our research more exciting and meaningful. Alright. So the outline of the 2 lectures will be as follows. First we will see what are the attributes of becoming a fully professional researcher. Then we look at the Professor Sternberg's theory of creativity. He is a professor in Yale University, US. Then we look at the 10,000 hour rule, okay, by Herbert Simon, Nobel laureate. Then what is the role of stress in research? All of you are doing research, so obviously stress is an integral part of research. So we need to be stressed, but we should not be too much stressed, okay. Then Sir Peter Medawar, Nobel laureate in medicine, in 1960 he got the Nobel Prize. So his ideas on research problems. Then what are the lessons we learn from lives of Nobel laureates? Okay, if you look at the lives of Nobel laureates, can we draw some inferences? Can we learn some lessons so that we can become better researchers? Then a traits of a creative engineer or a researcher, and then summary, and we will see what are the ways to improve creativity. At the end of the day, there is no point in saying all these people are great, all these people were great. Okay, they were great. From their lives, can we learn some lessons? Can we also improve? Okay. Okay, what is a PhD? In a lighter vein, so the y-axis, the ordinate is what you know, and the axis are the x-axis, how much you know about it. Okay. So if you are an undergraduate student, you get to know something about everything, but you get to know little about everything. Okay. And when you come to a master's level, you get to know something about, you get to know reasonably enough about many things, okay, and slowly your confidence goes down. You are having a doubt whether you know anything deep or not, okay. That is the situation of masters. When it comes to PhD, you know a lot about a very narrow area of. When you become a fully professional researcher, then you know completely about nothing. Okay. So jocularly I often refer to it as the okay, exponential law or the inverse law. Okay. If you think you know everything, you will get a BTech. If you begin to doubt that you know anything at all, you will get a master's. But if you are convinced that you don't know anything, but you are also convinced that others also don't know anything, then you get a PhD. Okay. The last step will be, if you are convinced that you know everything, if you are convinced that you don't know anything, if you are convinced that others also don't know anything, but you are also convinced that in your whole lifetime nobody can actually find out that you don't know anything, then you become a prof. I know I am on air, doesn't matter. Okay. All right. So this is the story of, so we try to know completely about such a small this thing, okay, that it is almost like nothing. Okay, you take a particular problem, solar energy, something, you have a parabolic, solar collector, this thing, you want to concentrate. Okay. So sometimes you have a doubt. When you proceed when you are getting so much of depth, will you not forget other things and all that? But the whole approach is, you get so much depth that your clarity about a particular thing, you keep doing a tapas on that for many years. You are getting so much depth into that, but through that depth, the darshan or vision comes, then your ability to expand other things radically improves, which you will not get if you just stop with if you are not doing research. Okay. So through that depth, your ability to perceive, understand other things will improve. So we gain width through the depth. This is about, that's why once you are a PhD and once you have gone through this process, your ability to appreciate, you can sit in a presentation in electrical engineering. For suppose all of you are mechanical engineers, you can sit in a presentation electrical, metallurgy, materials, whatever. then quickly you will be able to grasp what somebody is trying to say. Okay. In a lighter vein, okay, somebody has taken lot of years, his PhD is not over, after 7 or 8 he is growing a beard, okay, he is going to an astrologer, okay, and palmist, he is saying please look at my hand, please tell me when I will get my PhD. That fellow says there is no point in seeing your hand, please bring your guide, I want to see his hand. Okay, so these are all okay, this is in lighter vein. Okay, now this is also super creativity. Teacher asks Peter to expand a plus b to the power of n, he keeps on expanding like this. Are you getting the point? A plus b is expanding that. Okay. Then there is also an instant in a trigonometry problem where this is 3 centimeter, this is 4 centimeter, find x, x is root of 9 plus 16, 25, he says here it is. So you would have wondered, so you can very well imagine what grade Peter would have got in the exam. Okay. This is also an instant of creativity, but these are also instances of creativity, but we are not looking at this, we are looking at serious creativity. Okay. So this is familiar to you. So this is a variation of mass with time, it is exponentially decaying. Okay. This boy does not know anything about it. Okay. Then many times people do that, no? Then he starts explaining. It curves with a higher bit at the end and a rather aesthetically pleasing slope towards a pretty flat straight bit. The actual graph itself consists of 2 straight lines meeting at the lower left, blah blah blah, all that. That means he does not know anything about this curve. This is basically a y equal to a into e to the power of minus bx kind of curve. Okay, all right. So it is an exponentially decaying curve which have cooling of a first order system. Okay. If there is a hot object placed in cold surroundings, we look at heat transfer. Initially the temperature difference between the body and the surroundings will be very high, therefore it will cool very fast. Then the driving temperature difference comes down, therefore slowly the cooling will reduce, asymptotically it will reach the ambient temperature. Learning is also like that, learning will follow an inverse this thing, okay, it will opposite of this. Initially there will be explosive learning, it is applicable to PhD also. Initially you learn a lot of things, after 6 years, 7 years, 8 years the learning will become very flat, then it is the time to go, okay, because even if you spend many years it will get saturated. Okay. So that will be the inverse, you can very well imagine how that is also e to the power of something curve. Alright. Now we are not talking about those instances of creativity where somebody writes something or somebody for fun does something, but we are looking at some serious creativity. How do we become a fully professional researcher? See, if you are saying that you are a professional researcher, okay, what is expected of you? We have something to say that our peers want to listen to, that is very important. We cannot keep on claiming that I am a great researcher, I am a great researcher. In an international conference, in an international meeting, whether it is ASME or IEEE, are you invited to give a keynote lecture? Are 100 people ready to sit down and listen to you? Will they give that half an hour or 1 hour to you? We should come to that level. There is no point in I am great will not work. So, and that peer group must be truly international. It should not be a peer group only in Chennai 36 or Chennai 20 or in Coimbatore or Nagapattinam or Visakhapatnam or whatever. That peer group must be truly international. If there are 10 big experts, if there are 10 big experts in robotics or artificial intelligence, are you one of the 10? Are you one of the 20? That is what we want to aspire. That is what we want to get there. So to do this, command of our subject is required for this. So Rome was not built in a day. You cannot achieve this overnight. So soaking is required. It takes many years to get to this position. Okay. For example, Nobel Prize is not given to upstarts. After you finish your PhD, you found something very interesting. After 5 years, they don't give Nobel Prize. The first thing is you have to have a long life to win the Nobel Prize. Why? Whatever you figured out at the age of 25, 30 or 35, they will wait for 20 or 30 years, so that there is an opportunity for others to find out and prove or disprove whatever you said some 20, 30 years back. Therefore, whatever concept, whatever theory, whatever experimental results you have generated, have they withstood the test of time? Okay. So because time is a violent torrent. Okay. So there are many things which get swept off by time. So are your results having enough shelf life that even after 20 years or 30 years, people are ready to accept it, and no other paper has come, or no other paper has come which tries to say that whatever you have generated is erroneous and they are getting results much different from what you have got and so on. Maybe the accuracy may not be there, and after some years you may have a better computer, you may have better experimental methodology so that you can get some percentage improvement. But if somebody gets radically different results and they contest your findings, then we'll have to, then what happens is it opens up. That means the issue is not settled. When the issue is not settled, so it's not settled, then it is still an open problem for further investigation. Okay? So in order to do that, you need to have a mastery of appropriate techniques in the field. You should have a mastery of all the techniques in your field. For example, if it is thermal sciences, you should have a mastery of analytical techniques, you should have a mastery of numerical techniques, you should have a mastery of experimental techniques, because in your long life you cannot stay as just an analytical person, because the problems which are available which lend themselves to analytical investigation are slowly going down. In the 50s and 60s you can do momentum integral method, this integral method, approximate perturbation method, all that, similarity transformation, eta is equal to y by 2 root alpha t, all that kind of things, the kind of problems which can be solved using that approach, they have come down. Therefore, analytical methods have some place, but still you cannot, I mean, you should not, just as they say, you should not put all your eggs in one basket. Then if one egg is spoiled, all the eggs will get spoiled. Similarly, you cannot invest you cannot invest your whole career on analytical methods, because the analytical methods may themselves vaporize or evaporate. So your skill set must be all pervading. Skill set must be diverse enough, okay, so that the risk of obsolescence is not there. Okay. So if you proceed from analytical techniques, the next will be numerical techniques. You should have mastery of numerical techniques, because we don't have the luxury, the time and the money to have a research career where all our investigation will be based only on experiments. Okay. At the same time, you cannot assume that your whole life you will be working on some software like ANSYS Fluent. After 5 years, 10 years, some other different software will come, or those problems themselves will not be very important. Flow over a flat plate, nobody worries about flow over a flat plate now. Okay. Therefore, you should have mastery of experimental techniques also. So if you need to have the mastery of all these techniques, it takes time. Okay. So you have to spend time. Then also, once you are after your PhD, in your initial years after your PhD and all that, you should settle down to what is called a line of investigation. What is the line of investigation I want to pursue in the next 5 to 10 years? 30 years may be a difficult time, because maybe a difficult proposition, because lot of things will change. But the short to medium term, the next 5 to 10 years, where is it that I am finding lot of gaps? Where is it that I feel that there is lot of excitement? With my skills in analytical, numerical and experimental, my interests and my background, where is it I can make a contribution? This is a very important decision which you have to take. All right. You should be able to communicate your ideas through papers and presentations very effectively. Communication is very, very important. You should be able to give good poster presentations when you are a research scholar or a budding researcher, or you should be able to give good oral presentations in conferences, and then you should slowly develop the knack of writing very well, the art of communicating your results. Okay, it's not enough if you just got some great results. You should also be able to communicate. Okay, same thing. You figure out that you invented something which is highly creative. You may say it is creative, but other people have to accept, isn't it? Other people have to accept. Okay, because after all we live in a society and so on. The Apple iPhone became such a massive hit. The Apple iPhone is an icon of creativity because many people accept it, whatever they said, because they did something, they did many things which are unthinkable, like a phone without any keypad, and then there is no stylus, the finger will be used as a stylus. So they made when the market at that time was flooded with phones which had big keyboards and the screen was very small. Okay, and there was always a stylus at the back. Okay, so this ability to communicate your ideas is very, very important. So for this maybe you will have to do some reading. You will have to do a lot of reading which is outside your subject. You may do fiction, you may read fiction, you may read non-fiction, whatever. You have to do a lot of reading to find out how different people communicate their ideas in different fields. how a newspaper correspondent communicates his ideas, how a science writer communicates his ideas, how a person like Chetan Bhagat communicates his ideas. So you should get so by reading all this, you'll get an idea of how different people communicate in different ways, and pick and choose the best among all this, and then put your own spin and come out with your own formula, okay, for writing and presenting. And if you are in an academic setting, you should be able to guide PhD students sooner than later, okay. So your life doesn't stop with your PhD. If you are working in any, now even in CSIR labs and all that, you will have to guide students. So you should be a fountainhead of ideas. That means you should be able to generate ideas throughout. So the successful researcher is not somebody who is just very brilliant in maths or very brilliant in physics or whatever. The successful researcher is one who has the ability to keep on generating new ideas throughout his lifetime. Okay, so it should come. For that soaking is required, and then you should know what is going on in other fields, and then you should have your passion, you should have hard work. All these things will follow now. Okay, we look at all this in a little while. If you are in the industry, you must be able to write and defend your proposals. Okay, if you should be able to defend your proposal to your boss. So you are head of R&D division. Okay, you have to your finance and other marketing, all these people you will have to convince that please make this. I want to make a new engine. Then they will say I can get the engine from some other company. Why should I make a new engine? Then my USP is this, blah blah blah. So you say that I want a lightweight, this thing, high strength, whatever be your USP. Okay, so you should be able to defend your ideas. Then finally, the peer group must be truly international. Even in the case of industry, he is one of the top 10 guys in emission control. He is one of the top 10 guys in steering. He is one of the top 10 guys in ABS. He is one of the top 10 guys in networks. So we should try to get there. Only then you can say that you are a fully professional researcher. What are the attributes of a good researcher? First, you should have sound grasp of fundamentals. Very, very important. You should have sound grasp of fundamentals. That is why you cannot do research immediately after clearing your +2. You have to do your BTech, you have to do your MTech, then you do some courses, and so you should have lot of grounding. Then you should have mastery of techniques in the field. For example, all of you are doing heat transfer. There are certain techniques which are in heat transfer. The integral method, similarity transformation method, okay? How to solve partial differential equations, finite difference method, okay? Measurement of temperature, measurement of pressure, measurement of flow rate. Also these are all specific to heat transfer. Like that, if you are doing in electrical networks or communication engineering, there will be a set of things which you will have to master. So you have to you list out what are the things which have to be mastered so that you can become a fully professional researcher in your field. Then tenacity and perseverance. The experiment will not work, the program will not converge, the paper may get rejected. It may take a long time, the paper may be sitting with your guide for a long time. There will be lots of frustrations but in all these times you should show your resilience and see how optimally you will make use of your time. Stay positive, keep learning and keep improving. Then scholarship, you should have scholarship. That means you should have a deep knowledge. You should have a deep knowledge about your subject. You should also have a good knowledge of what are the problems other people are working in, what are the kinds of problems in this field where other researchers are working. You should know what are the problems your friends are working on. That is the scholarship. I know everything only about my problem. I don't care, I don't have interest in other things. Is not a good attitude. Is it okay? So you should know, for example, the top 10, the top 15, the top 10 or 20 researchers in heat transfer or thermal sciences. What are the kinds of problems they are working on now? What are the kinds of problems which are going on in your laboratory, not in your group? Your group anyway you will know, you will go for coffee with them and you will know what are the kinds of problems being investigated by other groups, okay? Other groups in other research institutes in our country, in our continent, in the world, okay? What are the kinds of papers which are being published in the latest journals in IEEE or ASME or in Elsevier? What are the kinds of work? So what are the kinds of work? What are the South Americans working on? What are the Americans working, North Americans working on? What are the Japanese working on? What are the Chinese working on? So for that you have to get scholarship, you have to read. Just I will work only on my problem, it gives you, it's like a frog in a well. Okay, you should have a world view of the kind of, because lifelong you cannot be working in this problem. 3 to 5 years down the line, your problem will be a well settled problem. They say, okay, you have done enough, you got here, then with your guide, you got it. You should not think that with that experimental setup, with that idea, I will proceed for 10 or 20 years. Then slowly you will get more and more rejections, and there won't be much fun and excitement in that. So sooner than later, you have to come out of your comfort zone and leave your PhD problem and do something. But whatever techniques you have learned will stand you in good stead in taking you forward. All right. Communication skills, I have already told you. Okay. So you can also look at YouTube lectures. You can look at NPTEL, you can look at OpenCourseware of MIT, you can look at other YouTube lectures, how different people communicate, present their ideas, not necessarily in engineering, how somebody presents his ideas in law, justice, psychology, physiology, whatever. So you get a perspective. Okay. Creativity is often neglected. So now we are going to talk about creativity. What is creativity? A creative person does things that have never been done before. Okay, the first thing is it should not have been done before. There should not have been an iPhone before that, Apple iPhone. Then only it is highly creative. Important instances of creativity: discoveries of new knowledge in science and medicine. The discovery of penicillin, okay, or acceleration due to gravity, universal law of gravitation. Okay, F equal to G m1 m2 by r squared. Okay. It is directly proportional to the mass of the two objects, it is inversely proportional to the square of the distance between them, and the constant is G. Okay. So, invention of new technology, the fluidized bed combustion, the fluidized bed boiler, where you can burn anything. You have a bed which has got high specific heat made of sand, then you put whatever you want, you put bagasse, this thing, all that, it will burn. That is a new technology. Composing beautiful music, whether it is by Mozart or A.R. Rahman, that is also creativity. Or take Indian Penal Code, take a particular section, some Supreme Court lawyer argues it in a way which nobody else has argued, that is also creativity. So, creativity can be in law, philosophy, or interpreting history in a different way. All these are instances of creativity. We should not think that creativity means new mobile phone, new computer, okay, internet and all this. They are all pervading, and many instances of creativity which are constantly going on. Okay. This Professor Sternberg of Yale University, numerous hypotheses and theories of creativity are available. If you put creativity, you go to Google, it will return you millions of sites, articles and all that. So I picked up this because I find it very, it gels with the theme of this lecture. So this is Professor Sternberg. He gives a list of what all qualities one should have or must have qualities in order that somebody is creative. He classifies intelligence into three types: analytic intelligence, synthetic intelligence and practical intelligence. This is from his book 1985, Beyond IQ, a triarchic theory of human intelligence, published by Cambridge University Press, that is indicated at the footnote. Analytic intelligence is what you learn in college. Mechanical engineering divided into 4 years. Each year divided into 2 semesters. Every semester you have 6 theory courses and 2 labs. Strength of material, dynamics of machinery, heat transfer, fluid mechanics, turbo machinery. If you learn all this, if you pass in all these courses, then you have learned mechanical engineering. That is the assumption. Okay? And then how do you test it? There is a question paper. Everybody is given the same question paper. Everybody is given some time. Nobody should look at each other's this thing. You should not look at books and this thing, and then you solve some problems. And the teacher has the answer to the problem. There is only one correct answer to that. Okay, so it is a highly simulated environment. In this thing, you then put first class distinction from gold medal, silver medal, whatever, and then you say that he is a mechanical engineer. So this analytic intelligence is basically we test your concepts, your fundamentals on problems for which solutions are already available. We are testing whether you can get the same solution. Rarely we give problems in which we give problems which are open-ended, where there can be more than one solution. Then it becomes difficult. Then somebody will say he got more marks, I got less. There are lots of problems. Okay. Therefore, often this analytic intelligence is theory class, lab class, exam, grades, and degree certificate. Okay. Synthetic intelligence is the ability to combine whatever you have learnt, okay, in a new way. the only place where you have a idea of the synthetic intelligence in your course is basically in your BTech and MTech is your project work, where you try to apply what all you learn to solve something. In research is all about synthetic intelligence, right? Whatever you have learned, you are making use. In a course based program like BTech or MTech, so the only way where you learn is doing project or in a design project and so on. And also in a synthetic intelligence, you can give offbeat solutions and different people can get different solutions. That is often the case in life. In life generally different people will take, now after this lecture is over, from 11:50 to let's take 12 o'clock to 1 o'clock, somebody can go straight for lunch, somebody can go back to lab, somebody can do, life is a set of possibilities, everybody can choose his own, okay. Then what the cumulative effect of all these choices is what you become, right. So the synthetic intelligence gives you the freedom that the solution finally is not fixed, there are different solutions. That's what normally happens in design. For example, in heat exchanger we always talk about two kinds of problems. There is a heat exchanger which is already available. You have what is called the analysis or rating problem, where you want to analyze and find out how much of heat can be transferred with this heat exchanger, okay. Then everybody will get the same answer. But now I have 100 kilowatts of heat to be transferred, I decide a type of heat exchanger, but how many number of tubes, what is the length of the tube, what is the diameter of the tube, that is a design problem, different people can get different solutions. Is it okay? Practical intelligence is the most difficult. Ability to adapt to everyday needs with existing knowledge and skills, and the ability to sell your ideas to funding agencies, managers, editors and reviewers. Practical intelligence is never taught, also extremely difficult to teach. You have to acquire it over the years. So practical intelligence is as important as analytical, synthetic intelligence. But if you see the triarchic theory of intelligence, out of the three, only one is excessively focused in all your education. So the other two you will have to pick it as you proceed. So your success eventually will depend a lot on the other two also, okay, and these have to be self-learned. Knowledge. What about knowledge? Knowledge gives us the ability to recognize what is genuinely new. Why can't you start research immediately after +2? I have a lot of brilliant ideas, let me start research. The basic problem with that approach is, first we should know what all have already been done in a particular field. Otherwise you will say the best way to transport is to have a circularly shaped object with hub in between and spokes, and then you will come out with the design of a wheel which is some 500 years old or something. You should not reinvent the wheel, okay. So only if you go to journals, only if you go to reference books, only if you go to textbooks, for example in heat transfer, you will know what has been done in the last 100 years. Only after you know what has been done, there is possibility for you to do something new. How will you know, how will you get to know what has already been done? For this, knowledge is required. You have to go through the basic courses, then you have to go through the advanced courses, then you will do the literature survey, then you will get to know what is already done. So some humility is required. You may have brilliant ideas, that brilliant ideas 100 people would have got and then 20 people would have tried and they might have been published and it would have also been a failure. So knowledge is very important because it gives you the ability to recognize what is new. You should know what is new, okay. It also gives you the skills to design experiments, design new products, okay. How do you design an experiment? How do you measure a temperature of 500 degrees centigrade? You may have a lot of ideas. You remember how to measure temperature. When I went to the clinic, doctor put a mercury in glass thermometer in my mouth. So you have got some brilliant ideas. I will use this mercury in glass thermometer to measure the temperature of liquid which is 500 degrees. Your brilliance will not let you know how to measure temperature. You should have knowledge. You should have a platinum resistant thermometer, or if it is surface you will have infrared. Therefore, you must know what other people have done. You should have knowledge. Creativity is one, but knowledge is very important, okay. How do you design experiment? How do you measure a flow rate? How do you measure pressure drop? If it is a huge pressure drop, you cannot use a U-tube manometer. HROG, what is the maximum HROG, how much, or you will climb a ladder to find out what is at H. Are you getting the point? So knowledge is very important. Then analyze experimental results. You are getting huge amount. The data logger gives you so much of data. How do you analyze these results? You should know there is something called heat transfer coefficient. There is something called Nusselt number. There is something called coefficient of performance. There is something called efficiency. Okay, so that comes from knowledge. And then you require knowledge to do scientific computing. I want to solve the equation d squared phi by dx squared plus d squared phi by dy squared equal to 0. First you should know that it is a partial differential equation. It is linear. Okay, it is elliptic. It requires boundary conditions on 4 sides. 3 kinds of boundary conditions are available. Then there are various ways of solving using, you can use a Fourier series, or you can use finite difference, or you can use finite volume, or you can use finite element. You should know the formulation. All this doesn't come from your brilliance. With brilliance only to certain extent you can go. It has to be supplemented by all this. Okay.